Welcome to this video. It's about sound. What is sound? In the last few videos, we talked about waves. In fact, sound is just an example of a wave. So sounds are just waves. How do you produce sound? In general, waves are produced by vibrations. So in the case of sound, sounds are waves that produced by the vibrations of some matter. For example, in musical instruments with strings, like a piano or a violin, the sound is produced by the vibrating strings. In other musical instruments, sound is produced by blowing a column of air. In the case of a human voice, our voice is produced due to vibrations of the vocal cords. Thus, the original vibration stimulates the vibration of something larger or more massive. For example, for a musical instrument with strings, there is a sounding board that starts to vibrate. In the case of a human voice, it's the air in the throat and the mouth. Now, this vibrating material then sends a disturbance throughout the surrounding medium, which is usually air, in the form of a sound that's longitudinal wave, as we explained in earlier videos. We know that sound waves with low frequencies below 20 Hz are what's called infrasonic, and humans cannot hear this type of waves because of the very low frequency. Sound waves with high frequency above 20,000 Hz are called ultrasonic. Now, humans cannot hear also ultrasonic sound. Sound are just waves, and these waves are longitudinal waves. Sound requires a medium. This medium could be a solid or liquid or a gas. In general, any substance, elastic substance, which is either solid, liquid, or gas, or even plasma, can transmit sound. In the case of liquids and solids, the atoms are relatively close and they respond quickly to one another's motion, and therefore they transmit energy with little loss. In fact, sound travels about 4 times faster in water than in air, and about 15 times faster in steel than in air. Now, for the speed of sound in air, it depends on wind conditions, temperature, humidity, and air pressure. The speed of sound in dry air at 0 degrees Celsius is about 330 meters per second. When the water or when the air is a little bit humid, sound will move faster. In warmer air, sound moves faster than cold air. Speed in water, as we said, is about 4 times speed in air, while speed in steel of sound is about 15 times its speed in air. Sound is just a wave, and so reflection is a normal phenomena of sound or of waves. Reflection means when sound encounters a surface, it returns, and usually and often this is called echo. Now, this is an important topic in acoustics, that's the study of sound. For example, in concert halls and theaters, there is a balance that's aimed for between reflection and absorption. In fact, some theaters, they have reflectors to reflect and to direct sound. similar to light. Another phenomena is called refraction of sound. Refraction means bending of sound waves, and this bending happens because of changes in speed of sound, which is affected by wind variations or temperature variations. And a very important application of reflections and refractions of sound in what's called the ultrasonic device that's used in hospitals and clinics. Using multiple reflections and refractions of ultrasonic waves, the device can create an image of the human organs. We know that dolphins, they emit ultrasonic waves to enable them to locate objects in their environment. Interference, we talked about this in previous videos. It's a property of all waves and not just sound. Interference means superposition of waves that may either reinforce or cancel each other. An application of sound interference, you can find it in what's called noise reduction earphones. So the destructive sound interference in noisy devices such as jackhammers that are equipped with microphones to produce mirror image wave patterns fed to operators' earphones. Now, these will cancel the jackhammer's sound. You can also find this application in stereo speakers. Now, you can notice that as the speakers are brought close to each other, sound becomes weak and diminished. Thank you for watching this video. Please watch the previous videos on waves in order to understand this video in much clearer way.